How do we humans perceive the things around us? We have five senses that help us to interact with the world around us. These are sight, hearing, taste, smell, and touch. Eyes help us to see things, ears help us to hear things. We smell with the nose, taste with our tongue, and the sense of the touch is provided by our skin. Of course, all the senses are important, but the sense of sight is the most important. Here is an interesting fact. We perceive almost 80% of the world around us by using our sense of sight. We see the objects around us with our eyes. But then, why don't we see these objects in the dark? The answer to this question is light. If you are able to see the objects around us, it is because of the light coming from these objects. The light from these objects travels in space and reaches our eyes. When it's dark or during night time, as there is no light, we are unable to see objects clearly. Here is how we define a ray of light. Consider a fluorescent bulb which is glowing. It is emitting light in all directions. So all these arrows represent various paths along which the light is traveling. These arrows are what we call the rays of light. Here's how we define a ray of light. A ray of light is a straight line path along which the light travels. The light emitted by luminous objects travel in variety of directions. Suppose rays of light from this fluorescent bulb fall on a surface, it being a non-luminous reflects these rays, and these reflected rays travel along a certain path. Consider this plane surface. Suppose one of the rays of light from the bulb strikes at this point. This is called as an incident ray. We know that this surface will reflect these rays and the reflected ray will travel in this direction. Why only in this direction? Why not here and here? This is because rays of light obey certain laws of reflection when they strike any surface. Draw a perpendicular to the surface at the point of incidence. This line is also called as normal. Here are the two laws of reflection that any light ray obeys. To understand the first one, we need to understand the angle of incidence and angle of reflection. The angle of incidence is the angle made by the incident ray with the normal. It is denoted by I. The angle of reflection is angle made by the reflected ray with the normal and is denoted by R. So our first law is that the angle of incidence is always equal to the angle of reflection. That is, I is equal to R. Here, as I is equal to R, if the incident ray strikes at this point, then the reflected ray will travel along this direction only, so as to keep R same as I. If I move the incident ray here, then the reflected ray will also move to keep the measure of R same as I. This was about the first statement. What about the second statement? The second one tells us that incident ray, reflected ray and the normal all lie in the same plane. So if I draw this scenario on a piece of paper, I will get this. Incident ray, reflected ray and the normal, all three are in the plane of paper. For example, if the reflected ray is in this direction instead of this, then the diagram will look like this. The incident ray and the normal are in the plane of paper, whereas reflected ray is not in this plane. This violates our second law, hence the ray will not be reflected in that direction. This is just not possible. It can be only like this. I will be equal to R and they will lie in the same plane. Now let's suppose that this plane surface is smooth. What do I mean by smooth? A smooth surface is a surface with no irregularities. However, no such surface exists. But a plane mirror is a pretty close approximation of that. Let a surface under consideration be a plane mirror. Suppose there is one more ray incident on this mirror at this point, which is parallel to the first ray. The reflected ray travels in this direction. What can you say about the two reflected rays? They are also parallel to each other. So if incident rays are parallel, reflected rays are also parallel. Similarly, if we draw few more rays that is incident on the surface of the plane mirror parallel to these ones, then the reflected rays will also be parallel to each other. This has some really interesting applications. We can think of incident rays as a bundle or group of rays parallel to each other. Reflected rays are also traveling in a group. So we can say that when a group of rays parallel to each other is incident on a smooth surface like a plane mirror, then each ray in the group gets reflected and all the reflected rays also travel together in a group parallel to each other. But note this is the case only in the case of plane mirror and a smooth surface. This is not the case for irregular surface. The above reflection of a light from a plane mirror is called as regular or specular reflection. Now let us talk about light reflecting from an irregular surface like this. And here as well, we assume that the group of rays incident on this irregular surface are parallel to each other. Where do you think the reflected rays will travel? Do you think that they will travel in a group just like they did in the previous case? To find that out, let us try to draw each and every reflected ray. The first ray is incident at this point. What is the normal at this point? Normal is the one perpendicular to the surface. Hence the reflected ray will travel in this direction. Remember, the angle of incidence and the angle of reflection always be same. What about this ray? Where will the reflected ray travel? Here the normal line is perpendicular to the surface, hence the reflected ray will travel in this direction. On the same lines, we can draw other rays too. So are the reflected rays traveling in a group parallel to each other? Not really. In this case, each reflected ray is traveling in a different direction. Such kind of a reflection from an irregular surface is called diffused or irregular reflection. Reflection from a smooth surface is called as a regular or specular reflection, while a reflection from an irregular surface is called as diffused or irregular reflection. Most of the surfaces that we come across in our daily life are irregular surfaces. A piece of paper, surface of wall are some of them. On the other hand, a plane mirror is a close example of a smooth surface. What other surfaces besides plane mirror can be considered smooth? If your answer was surface of water, then you are absolutely correct. Yes, surface of water, screen of your monitor, glossy paper are the few of the things that we can consider as smooth surfaces.
Now we know that the light rays can get reflected multiple times. For instance, when we stand in front of a mirror, we see our reflection in it. This is because of the light rays gets reflected multiple times. Multiple reflections is the result of multiple images. But have you seen multiple images of the same object? Probably you have seen it. Yes, inside a salon. When we are sitting inside a salon, most often we see two parallel mirrors fixed into the walls on the opposite sides of our seat. One will be in front of us and the other behind us. What is the use of the mirror at the back? It helps us to see the image of the back of our head in the mirror. We see the reflection of our front as well as back of our head in the front mirror. But do we see only one image of each? No, we see infinite number of images of both our front as well as back. It is the line of the images that goes on and on and on and finally fades away with distance. So we can say that when mirrors are placed parallel to each other, infinite images are formed. That's because of multiple images are formed. These multiple images are the result of multiple reflections of light rays. If I keep a candle exactly in between two perpendicular mirrors here, how many images will be formed? When the mirrors are kept perpendicular to each other, 3 images can be seen. Now the formation of 2 images must be obvious to you. These 2 images are formed due to the light rays from the candle falling onto their surfaces. What about the third candle you see there? How is it formed? The light rays from the candle, when the incident on the 2 mirrors, get reflected and forms this. These light rays are incident here and form something like that looks like one image. But is it one image? This part of the candle is the reflection of this image, and this part of the reflection is of the other image. But we can't consider this to be one composite image or reflection. In this case, the angle between the 2 mirrors was 90 degrees. When I reduce the angle between the mirrors to 60 degrees, we see 5 images. This one composite image is made up of 2 partial reflections. Let us name the images as I1, I2, I3, I4 and I5. We know that I1 and I2 are formed due to the light from the object only. What about the other images? These images that we are seeing here is the reflection of I1 as well as I3. The image I5 is formed by the reflection of I3 and I4. So we get 5 images. We see that as we decrease the angle between the 2 mirrors, the number of images keep on increasing. What if we reduce the angle to 45 degrees? We get 7 images. Amazing, isn't it? Now you must be wondering if there is a way to now find the number of images formed. Given an angle between the mirrors, there is a way in which we can find the number of images formed. The formula goes something like this. The number of images is equal to 360 degrees divided by theta minus 1, where theta is the angle between the 2 mirrors. This formula tells us the number of images formed. So when angle between 2 mirrors is 90 degrees, we substitute theta as 90 degrees. Hence, the answer is 3. Therefore, when the angle between the mirrors is 90 degrees, we get 3 images. We see that when the mirrors are kept at an angle of 60 degrees to each other, we put theta as 60 degrees. And the number of images we get is 5. Similarly, we can calculate it for theta equal to 45, and that is when the mirror is kept at the angle of 45 degrees. Yes, the answer will be 7. What if the angle between the mirrors is 0 degrees? Well, that is same as the mirrors kept in parallel. We get infinite number of images. Now that can't be used in this formula in this case, because if you put 0 as denominator, the answer will be undefined, or we say it as infinity. Hence, we can't use the formula when theta is equal to 0. When the angle between the mirrors is 120 degrees, 2 images formed. When the angle between the mirrors is 180 degrees, only 1 image will formed. So as we increase the angle between the mirrors, the number of images decreases. And remember, in all the cases, we are assuming that the object to be right in the central line. In the human eye, the light is focused on the retina. Retina is at the back of the eye and marks the inner layer of the eyeball. Retina contains lots of nerve cells that sense light. The nerve cells are of 2 types, namely cones, which are sensitive to bright light, and rods, which are sensitive to dim light. The message or sensation is then transferred to the brain along the optic nerve. Human eye has a roughly spherical shape. The outer part of the eye is called as the cornea, which is a thick white transparent wall which protects our eye from accidents and keeps foreign particles from entering inside. Behind the cornea, the colorful part of the eye is called as the iris. It has a small opening at the center called pupil. Iris controls the light entering through the pupil by contracting and expanding. Behind the pupil, there is a converging lens which focuses the light on the retina. Retina consists of two types of nerve cells, namely cones and rods. They transfer the message through optic nerve. There is a blind spot present in the eye. We know that the convex lens present in the eye focuses the light on the retina, and the retina has two types of nerve cells. These are called cones and rods. These cells transfer the sensation to the brain through the nerves. These transporting nerves are present in front of the nerve cells, and they are connected directly to the brain, and hence they transfer the message to it. They go to the brain through this region, and this region is called the blind spot. The junction of the retina and the optic nerve is called a blind spot. Unlike the rest of retina, this region does not contain nerve cells, and hence no signal is transferred to the brain. And that's why they say that every person is partially blind. It's because every eye has this blind spot. There is another interesting thing about the human eye, and that is any picture persists in the eye for about 1/10 to 1/15 of a second. That's right. It means that the brain retains the impression of the light for approximately 1/15 of a second, and after the source of the light is removed. That is a very little time. This is referred to as the persistence of the vision. Now I have many different images with me. Here's the first one, the second one, the third one, the fourth one, and so on. There are many such different images. Now let me take you back to the first image. Let me show these successive images slowly. I'll show you one image per second. Yes, this is how it will look. Now let me show the successive image at the rate of 2 images per second. This is how it looks. Now let me increase the rate to 5 successive images per second. How does this look? Our eye still notices the changes. And now I enter 12 images per second. It almost looks like a video, right? Then I show you 24 images per second. It looks like a video. This is because of the persistence of a vision. The changes go unnoticed. They appear to be a one continuous thing. When the images are flashed at a rate faster than 15 per second, the eye perceives the object as moving. The movies that we see also use this property of our eyes called as the persistence of the vision. What we see is nothing but the images shown to our eyes at a rate faster than 15 images per second. Usually this rate is 24 images per second. However, recent movies have gone up to 48 images per second. Imagine 48 images shown to your eye in 1 second. Our eyes are one of the most important organs providing us the sense of sight. Hence, we must take good care of them. First of all, if you are suffering from myopia or hypermetropia, we must consult an ophthalmologist immediately and follow what he advises us to do. If it is not so serious, he or she will most probably tell us to wear spectacles or contact lenses. If you don't follow the advice, the condition may worsen and you might have to suffer the pain of surgery. The second important measure is to avoid rubbing of our eyes. Yes, don't rub your eyes. This is a very bad habit which many people have. Whenever they feel itchy in their eyes, they rub their eyes using their hands. It may lead to eye infections. When your dust particles go into your eyes or you feel any kind of itching, wash your eyes with clean water. It removes all the dust and keeps your eyes clean. It's the age of technology. When you're looking at the computer screen or mobile, make sure that your eyes are some distance away from our screen. The minimum distance should be between 30 to 40 inches. The same also applies when you're reading a book. Make sure that your eyes are not too close to the book. Our eyes are very sensitive, so do not look at the sun or powerful light directly. Do not point lasers directly to our eyes. More than required light entering the eye is very harmful, and similarly, very little light is also harmful. Sometimes it puts more strain on our eyes and causes headache or even migraine. So don't work under dim light. Many eye problems are also caused by the lack of vitamin in our diet. So in order to keep these away, one must consume food which contains vitamin A. Raw carrots, green vegetables, eggs, butter, cheese and fruits such as papaya, mango are rich in vitamin A. The picture that you see on your screen is of a person named as Louis Braille. At the age of 3, he had injured his eyes, leaving him completely blind. Yes, he sadly lost his sense of vision. Being a bright and inquisitive child, he continued his education and invented an interesting system which today is known as Braille system. This is the system for visually handicapped people as it helps them to read and write. Let us study more about the system. The basic structure of the system, which starts with the Braille cell. As you can see, it is a cell with 6 dots arranged in 3 rows and 2 columns. These cells are named 1 to 3 from top to bottom on the left and 4, 5, 6 from the top to bottom on the right. Now on a piece of paper, some or all of these dots are slightly raised about their position. This is for the visually handicapped people to feel the dots using their sense of touch. This was just one Braille cell. There are many on this piece of paper that can be used to form long sentences and numbers. The dot height, cell size and cell spacing are uniform throughout. How many such patterns do you think can be formed by one single cell? This can be one pattern, this can be another, this can be one more, and so on. How many patterns do you think can be formed? There are a total of 63 dot patterns that can be formed. If we assume no dot raised to be a one pattern, then there are 64 patterns that can be formed. Each dot pattern can represent letters, combination of the letters and a full word or some symbol. Here's a list of combination of dots representing the things mentioned above. For example, the letter A is represented by this cell. Only the first dot is raised in this case. Similarly, the letter J is represented by this, but these 3 dots are raised. The dots 2, 4 and 5 are raised. So this is the set of patterns we have for the English alphabet.